Hi everyone, in this video we're going to learn to solve equations. Solving equation means writing the solution set. So let's start with the first example right away. I have 4x minus 7 equals to 13. Now the important idea here is whatever you do in the one side, you need to do it as well in the other side. You need to keep the equations in balance. How does it look like? So, to get x equals something, first I need to get rid of the 7. How do I get rid of the 7? The inverse plus 7, 13. Now, since I add 7 in one side, I need to add 7 as well in the other side. So I get 4x equals 20. Now, to get x, I need to divide by 4. So one side divide by 4. The other side divide by 4 as well. And I got x equals to 5. Are we finished yet? Not yet. You have to write the solution set because solving equation means writing the solution set. The solution set is 5. Now, I know most of you already know this, but I want to emphasize on the correct idea. We're not just doing the so-called pindah ruas here or moving the number, the terms to the other side, but actually we are keeping the equations in balance. Yeah. But of course, if you are already comfortable with this, you don't struggle with the signs, you can do it simpler. Equals 13 plus 7 and then 4x 20, so x equals to 5. This is still acceptable. Don't forget to write the solution 5. Now, to write the solution set depends on the domain of the variable. When it is not stated, we assume that the domain of variable is real numbers. But it can be something else as well. Now, what does it look like? I will show you in the next example. Here, you are asked to solve 3x minus 4 times x plus 5, but this time, the answer or the solution will be within the domain of integers only. Okay, so let's first solve this equation. 3x minus 4 times x plus 5 equals 0, meaning one of the term can be 0. It can be the 3x minus 4 equals to 0, or it can be the x plus 5 equals to 0. And here I got the x equals to 4 over 3, but in this side I got x equals to negative 5. Back again to the question. The domain of the solution is integers, which is integers from the answer. Yes, it's negative 5. So our solution here is only negative 5. So you see, if for example, so it's just extra, if the question asks you or giving you information that the domain is positive numbers, then of course the solution will be different. The solution will be 4 over 3. But if nothing is stated there, it means the domain is real numbers. If nothing stated. So both answer can be the solution. Both the negative 5 and the 4 over 3. So that's talking about domain of solution. Domain, this is how you spell domain. Okay, let's go to the next example. Now, this is where I want you to pay careful attention because sometimes we are confused between the two. So the solution for x equals square root of 25. Square root of positive number is always positive, so the solution is only 5 here. What about square root of negative number? Well, that's imaginary number. We don't have solution for that. Meanwhile, if we have x squared equals 25, the solution can be positive or negative square root of 25. I will have two different solutions here. It can be positive 5 or negative 5. You see, if I do 5 squared, the answer is 25, but negative 5 squared is also 25. So we have two solutions, negative 5 and 5. No domain stated here, so we assume that the domain is real numbers. That's why we write both negative 5 and 5. So this is the difference between the two, yeah. The square root of something is always only the positive one, but if I have like x squared, then the x can be the positive or the negative number. Okay, next. Now, how do we solve expression within absolute value? So let's recall again what an absolute symbol do to a number. If I have number 4 inside absolute value, it will be positive 4, stay positive, yeah, not changing the sign. 4, positive 4 will stay as positive 4, and negative 4 will also be positive 4. So always positive for the absolute value. So if I know that what's inside makes positive 3, there are two possibilities. The inside here can be 3, or it can also be negative 3, because negative 3 inside an absolute value, absolute symbol is also positive 3. Now, to write the solution, we can write, so the x minus 2 can equals to 3 or equals to negative 3. Now, just solve it. X equals 5. Here, x negative 2 plus 2. So this is equals negative 1. So our solution is negative 1 and 5. Okay, so if you have an equation within absolute symbol equals to a, then the fx that we need to solve can be a, can also be negative a. Okay, that's how you solve within an absolute value symbol. And you might not see this a lot, but you can encounter problem like this. So here you see there's no answer, like there's no solution for this type of problem, because like if I subtract with x, it will be 3 equals to 0, which is incorrect because 3 is not equals to 0. So no solution. What do we write when we have no solution? You write an empty set, or you can also write it this way. Same here. Solve to x minus 4 equals x plus 8, but within the set of irrational. So 2x minus x equals 8 plus 4, x equals to 12. It seems like we have an answer, but the answer, the solution should be inside the set of irrational. And 12 is rational number, not irrational. It means we don't have any solution where the answer is an irrational number. So the solution is empty. Okay, I think you've learned like different types of solving equations already. Now you see that I use different color because you need to be careful here for the extraneous solutions and irreversible steps. Why? Because mathematically it seems like we're doing a correct steps, but actually the solutions we get from doing this step does not satisfy the original equation. So it's like you're making new equations different from the original one. Let's start with x equals to 5. Clear here, our solution here is only 5. The only value that satisfies x is 5, right? But what happens if I do multiply with x minus 2 in one side and with x minus 3 in the other side? It seems okay because we are following the balance rule, but actually in here I produce a new solution, which is 2. You can see by yourself when I write 2, equals 5 times 2 minus 2. I got 2 times 0 here equals to 0. 5 times 0 here equals to 0. This is still correct, but the 2 equation is different. Now, the 2 here is what we call as the extraneous solution, because it's a solution not for the original equation. It's the solution for the transformed equation. Again, it does not satisfy the original equation. Now, why does it happen? Because you multiply it with an expression that can equal 0. So, whenever you multiply an equation by expression which can equal 0, this will produce extraneous solutions. Okay, so why is this not allowed? Because it is irreversible. That's why it's called irreversible steps. When you multiply by 0, you want to reverse it, you divide by 0. But dividing by 0 gives you undefined answer. Divided by 0 is undefined. That's why it's irreversible steps, which will produce transform an extraneous solution. Nah, so be careful ya, don't multiply it with expression which can equal to 0. But in the other side, you need to also be careful with this. Now, here I have x squared equals to 4x. So for x squared equals to 4x, we have two solutions. It can be 0, it can be 4. But if during solving the equation, you divide both by x, you will get x equals to 4. You lose one possible solution. Why? Because you divide it by x, while x can be an expression that equals to 0. That's why it's incorrect. It's like the irreversible step that we did before. We cannot divide with something that can equal to 0. So you also have to be careful with this. Don't divide by expression which can equal to 0. Okay, I guess that's it. Thank you.